So you may know that this year marks the 50th anniversary of the moon landings, and that amazing event is arguably one of humankind's most fantastic achievements. This event captured the imagination of people around the world, but radio telescopes captured the images from the moon, which were then beamed to TV sets worldwide. One of the telescopes used was the Parkes Radio Telescope, which you can see in this image here. You might recognise the Parkes Radio Telescope. It's an iconic Australian telescope, made famous by the movie The Dish. If you haven't seen it, you should definitely go and watch that. But you might have also seen this telescope if you've been driving to Queensland as it pops out along the Newell Highway. You can't miss it. At Swinburne, we use this radio telescope to make measurements of galaxies and spinning, rotating neutron stars. And we try to understand the mysteries of the universe. But NASA uses this telescope to be able to get signals from their deep space probes. And this highlights how astronomy and space technology are very interrelated. So Neil Armstrong and Buzz Aldrin's first steps back in 1969 marked the end of one of the great space races of the 1960s. We're currently undergoing a new generation space race, and this has been driven by huge advances in technology and manufacturing. So these days, we're able to build very light and small CubeSats. CubeSats are very small satellites, and this means that it is much easier and faster to build satellites. In the past, large organisations such as ESA and NASA have had deep space missions as one of their primary aims, and this is still the case. This is illustrated by the recent landing of a probe on the other side of the moon, and also exploration of our own solar system, of Pluto and beyond. But the real growth in the space industry today is in earthbound observations and communications. So these satellites are very small and agile, and one of the biggest costs when it comes to space technologies is the cost of launching something into space, and that is driven by the weight of the object. So the fact that we can build very small satellites means we can produce them on a faster scale, but they're also much lighter and cheaper, and that brings the space industry down to industries that are much smaller in scale to the everyday industry. And this used to be just the realm of NASA or ESA-like organisations. This CubeSat that you can see here is actually a CubeSat that we're working on here at Swinburne with Melbourne University and other universities around Australia. It's called the Skyhopper Cube Satellite, and it's going to be Australia's first space telescope. Mounted on this CubeSat, which is, once again, it's going to be a very, very small satellite, will be a cryogenically cooled infrared detector, one of the first of its kind to be launched into space. We're going to point it at the heavens, and we're going to look for things like gamma ray burst, distant galaxies, and planets orbiting nearby stars. But the technology that we are developing for this particular cube satellite will be utilised in new technologies and new detectors that will be then very applicable to earthbound observations. Infrared detectors in particular are of great interest for monitoring